Okay, so before the break, we were looking at a few things we were out of time for last week. The beans and then the Java stuff. And I just thought of something that y'all would probably figure out really quick, but I quickly said it about the Java docs, but I want to make sure to point it out because you would probably figure it out pretty quick. But if we just set up those Java docs and include the package info, which would have all the detailed description about our package. Usually we'd have a bunch of HTML code there and more details down here. A nice thorough description. But something else you might want in there is there's a good chance you might want an image in there, right? So where do we put the images for that? Let me just make a quick image. I'll just go to paint and grab one of the brushes. Watercolor, that'll work. And do a quick watercolor smiley face. Oh, ran out of water, I guess. There we go. Awesome. So just a quick little image. But where do we put this in order for those Java docs to know where? You probably would have figured this out pretty quick because if we go in the project, in the distribution folder is the JavaDoc folder. And then there's a bunch of different things, index files, resources. I guess as long as we can navigate to it, the main thing to keep in mind is that this is the files we're going to put on there. Everything called JavaDoc, like if we want to run that from the GitHub page, that's what we would rename. We would rename that as docs. That way GitHub knows what to do with that folder. So this is what we're going to put on there. So anywhere in here that you can navigate to, you look around at the files, it might help, and you would probably figure it out pretty quick. Here's our index, our home page. That's the one we want to refer. So right here at the top level is where this would need to go. But it would be just like any HTML page, just if it's somewhere buried down inside some other folders, make sure you put the address to it explicitly or stick it on the top level and make sure you can get back to it. So say this will work, I'll call it smile.ping. So then over here, source is smile.ping. That'll work. Don't need anything fancy there. I feel confident y'all would have figured that out pretty quickly, but since I did mention images when I said that, probably not a smiley face, probably something more useful, like class structure, hierarchy diagrams, use case diagrams, something useful, but that gave us a problem, right? Building index, build failed, JavaDoc returned one error, lots of warnings. It's hard to see what's going on with it. And it's really this picture that's causing problems. This HTML code here, it doesn't seem to like this. One error, 24 warnings. Did it create the thing now? I deleted the pictures. If I bring the picture back in, open that, we get the can't find it message. So what would probably be your first guess on where to put it, see, causes a little bit of a problem. We get error messages here on that. So you can see why I decided I should probably show that. Cannot find smile.ping. If we look here, Java doc object 2 example package summary is where we're actually starting at. So the thing labeled index page is not our starting point on the Java docs. All the index does is forward to another folder. That's where that initial guess might have gotten off, and you have to look around to find it. But there's ways we can find it, right? We see the file path right here when it's opened locally. So instead of storing that here, let's cut that and go in here. Oh, there's package summary. So if we want to use the name, we need to put that right there beside it. Or put it in another file, but make sure when you're trying things out and looking around, pay attention to things like the address. We expect it to start at index page. If you don't open up that index page and look at that, you'll find that all the index page does is forward to another page. So make sure you're paying attention to where you're looking at stuff. So there's how we get images in. Probably more useful image flow, flow charts and use case diagrams and DFEs and state transition charts and useful diagrams, but that's just putting a picture in. We can put one picture in, we can put any picture in, right? So otherwise you'll see it's just the HTML image tag. At least that's how I do it. There's more than one way to do everything. The HTML image tag is definitely the easiest one to remember, because then we don't have to remember anything special. So yeah, it's a web page. Stick it in an image tag. So the next little concept I want to talk about is all the basic idea of a class. Right? We've kind of started building on that, and it's going to extend a lot. It's a data type, and we would set up some data fields. We're fine, like integers, right? There's lots of integers. We just set a field, and then anything that fits as an integer, we can store there. That same thing with strings. Booleans, obviously, our options are true or false. We might think the words yes or no, or up or down, or something that fits the situation better when we're working with our algorithm, but we still only have the two choices on the Boolean. A lot less choices there. It's easier to deal with short choices. Sometimes we do have a short list to work with, right? Like that last example, the vehicle make model. That's a standard thing. Make and model. And there are lots of them, but there's not an infinite amount like there are integers or fractional values. The fractional infinity is larger than the whole number infinity. There are different sizes of infinities. We have more values between 0 and 1 than all of our whole numbers put together. But there's unlimited choices there. If we're talking about car manufacturers, the make on a car, there's a short list, right? Well, we got Ford, GM, Chrysler. It's kind of a long list. I mean, there's a few things there, but it's a very restricted list. It's a short list. We don't need every possible option. I was right, ... I'm going to work this, go back to an animal example. Maybe work it into our actual animal example. Let's go back to the animal example from last week, and we'll put it there when we get to the syntax. But another very common example is a fan. Because one thing about a fan, fan's going to have a speed property. A couple of y'all know what that syntax means, right? You've seen that, right, Bradley? Your C++. I'll just write it that way. The fan has a speed property. And what is the speed on a fan? We don't have an infinite number of speeds, right? Usually our options are going to be low, mid, and high. And that's the full list of options we can have for a fan speed. We don't need to have a completely open data field when there's only 3 possible options. Same thing, this one has a much longer list, but there is a finite number. We could make sure that somebody's choosing from a drop-down list of options, not typing in any possible word for the car make. Same thing on our animal option. There's a short list, right? Animals are going to have scales, or fur, or feathers, or slime. I think that's all our options, right? The things that don't, fish have scales. Everything else in the water, if it doesn't have scales, it has slime. Same thing on land. It's going to have fur or scales or feathers, except maybe slugs and snails, maybe a shell. But there's a short list of outer coverings for animals, right? We'll just do 4 or 5 in there, but a very short list. So we don't need every possible option. We don't need to make that a string where people can type in just anything. It's sort of a short list. And that's where enums come in. We try a different marker. Oh, that's better. So the idea of an enum is kind of like our short list. It's short for enumerated. And this gives us an advantage that that a lot of people like in Java. Something that we said last week not to use, but this gives us a way to buy that back. We'll see that in a few minutes. But enumerated, it's a finite number. There's a short list of options. That's basically what it is. We want to set that up and be very formal about it. Be very formal about what that short list is. Yeah, that's pretty much all I have to say about them. They're very simple things. It's a special sort of a sub category of things. I pull up my example syntax so I don't accidentally skip anything. Wait, I thought it was from this last one. This one. Yeah, that's it. Oh, no, that's not it. Sorry, my examples are in from 2019. I kept doing everything in I was doing everything as Maven projects. So when I go to pull up an example, there's a whole bunch of files to dig through here. So I have to go in the source folder, then the main folder, then the Java folder, the com folder, my company folder, creatures folder, and oh, that doesn't have the example I was looking for either. I just pulled it up right before class, so I thought it was in one of these. That structure is debugger. Grades would be another example of pulling this up, right? There's only so many grades to go around, A, B, C, D, F. So we want to make sure that something is pulling from that short list. Okay, maybe I'm just looking at the wrong year. This is not fall 2019. SDEV 200. From laptop, projects. Sorry, I looked at what folder this was in right before class, and apparently I remembered it incorrectly. There we go. Nope, that doesn't have it either. Well, I can't remember where my example is. Guess I didn't need to get that computer out. So hopefully I think I got all the things I want to put. We just need that short list of options. Is really what it is. So I'm gonna go back to the animal one because it has a more obvious short list than the cars, right? The cars, we want to get down into subclasses before we got to the short list. But on animals, that covering thing I just mentioned. So this example is on that GitHub as well. So if you need to grab the source code. But our animal, any animal we talk about is going to have there's a short list of types of outer coverings it's going to have. I guess spines are a common one too. Something to poke things, something defensive, poking things. Then a bit more specific, I'm just going to make a short list. So instead of adding a string for any possible covering somebody's going to type in, right? Because they're going to have lots of different things. What does a porcupine have? The hair, the quills. What is a sea urchin covered in? I was watching this video yesterday. Apparently, if you put little hats inside near sea urchins, they'll put them on and wear them. And it was just the funniest thing I've ever seen. I thought they'll just be crawling around and they keep having to adjust it because sea urchins roll when they move. And they apparently know to keep the hat on top of their head or on top of their body, which is something really funny that if you want some of nature to laugh at, that's a good thing to look into. Sea urchins wearing hats. Lots and lots of video about it. But lots of different coverings. So we might want something to do there. But our basic primitive data type is not going to work. Because maybe an integer where we correspond things and do a bunch of selection structures. We need a way to shortcut what I just said. Assign integers to it. So then we get back things like equal, equal. The two equal signs, the normal way we want to do equal. Check equality in a condition. We can do that. So let's make a new enum here. I'll just do generate things. So I'll come to the package, a new, I'll go to other, and under Java, you'll see it's the third thing on the list. There's classes, that's our objects. The design for an object. An interface is when we set up rules that an object has to follow. Rules for a class that a class has to follow in order to work in our project. Or third one down, enums. And the fourth one down, I said we're going to do this, look at this one later, annotation types. So we can make our own annotations. We'll see that later. Enums are something very, very useful. I'll make a new one called covering. The outer covering, like everything has skin, but every animal has something different coating their skin. So I'm just going to make a short list of the things coating the skin. For the example, hopefully this will make sense on how to use the list. So it's the syntax. Get rid of these unnecessary things. And yeah, the JavaDocs will apply here. It will, you do your JavaDoc comment exactly the same in the enum. You put it over to enum as a whole, because a lot of times we do not put methods into our enum. In a lot of languages, we cannot put enum methods in our enum. Java will let us put methods in here as well. So once we have that short list, we can go ahead and assign methods to the things on that short list. So we'll see both of those. But for covering, what type of things can we cover an animal with? I'll start with underwater. We'll have scales, which these are constants, right? There's a short list of constants, so I'm going to go with all caps. just to follow that convention. Usually, yeah, the short list is like a short list of constants. We can only choose from these constants. So we'll follow that all caps convention for constants. Scales, slime, I guess would technically be mucus. I'm gonna call it slime. Because there might be different. Some animals might have something different than mucus, but everything I'm thinking of, eels and squid and stuff. Yeah. There are other holes and natural living organisms where stuff can come out of, but I'll just say slime. Oh, no, I don't want to stick the keys. Things could have hair, feathers, spikes. Sort of obviously that list could be a lot better. A veterinarian would have more specific terms for what we were using this example for, but there's not many things that would cover that outside of an animal. Outside the skin, everything has skin, but then everything has something different on top of that skin. That's probably good. That's enough to see the syntax. Then a semicolon. There's a comma separated list of the values that we're allowed to have, the possible values. So the fan example is a common one. If we're going to simulate a fan, there's going to be a speed, and the speed is only going to have that list low, mid, high. So I'll save that, and that's going to be a property of our animal. So we'll come over here and make that a data field. So a private covering data. So just like our objects, it's a type. It goes there with int or string or Boolean. It's a type of thing. There's just a short list of things we can have. Private covering, covering. I can't think of another word quick enough. So we have that private data field. I'll just add it in our constructor here. Wait, then covering, and then this dot covering equals cover. I'm going to scroll over a little bit more. I just kind of threw it in the middle. I like to put things in a certain order, and that order includes Booleans at the end. That's just personal preference. So I didn't put it right at the end, but our constructor is expecting some covering data to be passed in, and then we'll just assign it to that. And might as well generate our getters and setters for that down here somewhere. I'll just find a nice little empty spot, right click, Alt insert, and put in getters and setters for the covering so we can change it. All things we've seen before, just sort of the basic setup, maybe add it to the string. So maybe Fluffy is 4 years old and weighs so many pounds plus, and is covered with, and I'm just going to put dot for now because we're going to come back and put that in. But the idea of we want to include that in our string somewhere. Right now, all we have is an internal working, right? We say we have covering data, but we haven't talked about what that means. It's kind of hard to say that's going to go in our, exactly what's going to happen with that in our string. We'll see that in a moment. But if we come back over to our main, I guess we have to change all these objects now. So a cat is going to have covering data. I'll just call it covering again. And this time I'm copy and paste that into all the other ones. Actually, can I do this with a shortcut? Oh. In Eclipse, there's a shortcut we could do where we could update all of those at once. I'm pretty sure there is one, but I don't know what the shortcut is off the top of my head. And don't need to waste time looking for it, and copy and paste will work. So that'll add that, and then we'll pass that in here. Pass covering just right back up to the super object. On the dog, get some covering data and pass covering data up to the super object. On the gorilla object, taking covering data and pass that right up to that parent. Same thing on all of them. We just need to add it to our constructor and pass it right up. So you can see there's not really a lot of thought in adding that to the constructor. So I'm quite certain there is a shortcut. I just don't know what the shortcut is off the top of my head. And copy and paste seemed quick. Okay, so now the only thing wrong is where we instantiate those. So we need a covering for a line. I think everybody knows what type of covering the line has, right? It's gonna have hair. So if we try to type in a string, it's still gonna tell us that's a problem. We do need that specific short list we create. So it's covering type data, covering dot, and then from the prediction, we just pull up hair. So the next one, it's a line again. So again, it's got covering dot hair. Are these all mammals? Yeah, these are all mammals. I'm gonna make something non-mammal. We already saw that the mammal one works. So maybe fish. We haven't done a fish. We haven't made a specific class for fish. We'll just make that a generic animal, right? Animal. Call it fish is a new animal. It needs a name. Oops, sounds like a fish name. I don't know, 4 years old. Goldfish live a surprisingly long time. I was thinking about that earlier today and realized my goldfish are 13 years old. Like, I did not know goldfish lived that long. I had no idea. And actually, I bought them as feeder fish. I just needed some for a hydroponics garden. I like to grow fresh veggies in my living room, so I have like fresh veggies in the middle of winter. By the time that even the stuff at Kroger is probably a week old. So I just needed fish for a hydroponics garden, and I've had those goldfish for 13 years now. I did not know goldfish lived that long. But a little side, so yeah, a few years old. Goldfish are definitely small, maybe a pound. A pound's probably like a full-size koi. I don't think fish are very heavy. What else do we need on the fish? Oh, then the covering. So covering scales on a fish, and I guess true is just a normal checkup. I remember what that situation was for. We also need an eel. Oops. We didn't set one up, so I'll just make it a regular animal. Do animal. Are there any famous cartoon eels? I can't think of any. Seems like there was one in. They're always like background characters, like swimming around behind the Little Mermaid, or electric eel shocking people. I can't think of any, I'll call it Slick. That seems like a good eel name. 2 years old, weighs 5 pounds, maybe a big eel. Covering slime. And we have that short list to choose from. Maybe false. Eels swallowed something eels shouldn't have swallowed. Gotta have the vet check on it. I know for Japanese, like in Japanese setups for aquariums, eels are some of the more expensive ones. I recently read a story about, I've been reading about what they did with animals in zoos during the lockdown. A really surprising fact is when they described how most of the animals in the zoo started acting, it fits the stereotype of the Hollywood starlet that's past her prime. I thought that was a really interesting perspective on how the animals in the zoo view themselves. They all started acting like the stereotype of what Hollywood actors get after their.
I'm ready for my close-up.
Yes, exactly. So it gave a new way to deal with that. Japanese people, they started actually FaceTiming with their eels. Their lockdown was so strict they couldn't even have the caretakers get in there, so they just set up an iPad there and we're FaceTiming with their eels and we're getting better response. But there's some really interesting research came out of how the animals in zoos were acting when the people quit coming around. It definitely had a big impact on them. And they were very, very overjoyed when people started coming back around. Which I guess makes sense because most of the people that go to the zoo are except little kids that are super excited to see them. So there's lots of happiness there. I guess that's enough to see the syntax here, right? So we can print out our fish and print out our eel. So we have that short list of coverings. We don't have just an infinite number of strings that can go in there. Have to choose something from that list. When we run it, well, no error messages so far. The big thing is we needed, it makes our code look nice when we do it that way. If we thought of some sort of personal coding, like I said, hair is number 1, scales are number 2, or some sort of even strings, we're the only ones that know that. So our short list is very self-documented. Other people can look at it and make sense of it. It gives us words on there. For anybody that's messed with IoT stuff, microcontrollers, Raspberry Pis and stuff, we usually don't type 1 and 0, right? When we turn our GPIO pins on, our general purpose in-out pins, we use the words high and low. They're enums. We have that short list of meaningful things. Because we don't have 1 and 0 is for a machine. High and low makes a lot more sense to human. Is it on or off? What are we doing with it? Anytime we have that short list, it can be beneficial to do so we put it to words. Then this thing, if A1 dot equals A2, we saw that, right? What we normally think of as equality, which we learned when we first started learning program, equal. We saw some in Java, so we don't want to do that. Because equal only refers to the same spot in memory, which for most of our data is kind of big. It's going to take the Java machine a second to get that in memory and figure out if it's already in memory and then make adjustments cleaning it up. In most cases, integers are different. Integers are kind of like our most primitive data, right? So our most basic type of data is that just however many bit integer, bytes, booleans, any of those. We enumerated this. So this is kind of like a number. Really, enumerate means that we made a finite list. We made a short list. It's something that is countable. We might not know what that count is ahead of time, but we know there is a number we can count to. We won't just count forever. Enumerable is not infinite. But it kind of equates it to those things. So some people like how we can use the equal sign again, if we check that. So like A1 dot covering is holding an enumerated value. We can almost treat it like an integer and use our equal to again. Oh, whoops. If we remember the private public access. So we don't want covering, we want get covering, which is a method. But when we get that value, we can treat it like a number and use the equal, like we learned when we very first started learning the program. Some people really like doing that. It gives us a way to do that. So if we run this again, you'll see those are equal. Or not equal. And we can do that because really Java has some of the best garbage collection out there. It's only going to be a couple of milliseconds before garbage collection figures out that that value is already in memory and adjusts it so two equal signs can work. But we cannot guarantee that our line is going to run in that couple milliseconds it takes. And we don't have a way to guarantee that the garbage collection is going to do that first. But this is a finite list. So like an integer, the Java virtual machine knows it has time to put a finite list in memory before it does something else. So we can kind of treat it back, get back to that equal. Some people like it like that. If you're already missing the two equal signs instead of the equals method, the enums do give us a way to give that back. But the big thing is it's the short list, the finite list. We know how many options there are. There's some advantage to come off that, including the explicitness. Other programmers can look at that list and figure out what that word means. They don't have to figure out what we encoded a 3 to mean, or some sort of messy looking string that made sense when we wrote a code, but doesn't make as much string sense as something specific. That's the basic idea. Most of our major programming languages have enums. Java does take it a step further and allow us to put methods in enums. Usually we have to use an enum to run a method in the main part of the object. But with Java, we can actually put a method here. So make a public method. I'll return a string with it. Public string called describe. Not going to need anything. And what we were just talking about, back to that word in enum, is abbreviation for enumerated or enumerable. Anybody want to guess what the best way to choose between those values would be? It's a selection structure, so we only have two choices, right? You can have an if else or a switch. Which one do you think would be better? Yes. If y'all didn't hear him, he said switch. Because there's a short value, right? 1, 2, 3, 4, 5. There's 5 switches we can hit. And we'll never have anything in between those switches. Nor will we have a mix-up. We won't have switch 1 and switch 4 on. It's one particular thing each time, and it's only going to be that thing. It's enumerable. It's countable. There's a definite, not infinite. So we can run a little switch case on this. We didn't put the word class here But hopefully it still makes sense how we can use this word here. Right, we're going to create an instance of a covering type data. So the word this refers to that instance that we're going to create. It's just a very special type of class. It's not a generic class. We can make an enum with class syntax, but it's so common we have a specific enum syntax instead of having to make it with a class syntax. Abbreviates a lot. Obviously, we can't do just a comma separated list if we use a class syntax. That would be the normal class data fields full of constants. So private, static, final, string, hair. Then we're going to switch on it. So our first case is that it's hair. I usually put the covering in front of it, but yeah, you can see it works with just the stuff in the enum. One of our options is hair. I should probably put that in the same order, shouldn't I? Scales. And I always type these this way: case slime, shift tab to get back out, and then case hair, shift tab, case feathers. And I always just write out all the cases and then come back and do what to do on each one. Case spikes. Oh, and then a case default. We don't want to forget our default case. Oh, whoops. We don't need case for default. After all the cases, then just the default. Sorry about that. That's the way I like to write switch cases. I don't think every single line top to bottom. It's more of an overall left to right. All the stuff that's not indented, all the different cases we could have. Then I'll come in and do the indented stuff for it. So if it's slime, return something that'll fit in that sentence we started there, and is covered with a slick, gooey mess. That sounds good. Return a slick gooey mess. And then break out of that one. So our normal syntax for that, return the string, what's that? Underline. Oh, we're returning. When we return, we jump out of the method. So we don't need to break. You're probably used to seeing the word break in things, but if you're in a method and going to return afterwards, you can't reach a break. You can't reach anything after the return statement. Oh, whoops. That was supposed to be the return for slime. So scales, small, hard, overlapping surfaces. Hair, return. What's the generic description of hair? Thin. Thin strands covering thickly. I don't know, there's probably a better sentence than that. We're just looking at the syntax here. Some sentence, you could just return hair, right? It's covered with hair. I was trying to get some sort of description going. Like, back to the vet's office thing, what it should be. So, like, if the eel is not covered in a slick gooey mess and is too sticky, or it's starting to get hard, then it's indicating something's wrong. I guess we could just return that word pretty easily and it would still make sense in this case. Small bundles of strands linked on a stem. That kind of sounds like a feather. Return many pokey things. Something like that. Some random words. We're just looking at the syntax. But you see our method has something to return. Return an outer covering for the string, for the skin. Some sort of default sentence. Nothing new there, except we're switching on the object itself. So on it, we can pretty much only put this in when we do an enum. If we do any class, we need to be more specific. We need this dot something. But since an enum is just a short list, we can just switch on this itself, as in the keyword this. And that gives us ways to describe those coverings. So when we create our sentence here, and is covered with, oops. Plus this dot get covering dot describe. Or you'll also notice right below it. Anybody have a guess on what the name is? I'll give you a hint. That's why I didn't put return hair, return scales, return fish, or return slime. We have a way to access that name directly if we want it. Or convert it to a string. Y'all can play around with those things. We created a describe method, so I'm just going to use the describe method. So now when we run this, look at that nice little sentence there. Oh, except I forgot a space. I put a space in there. Normal debugging. So our lions are apparently covered with thin strands, covering thickly. That doesn't sound like a correct sentence, but y'all know how to fix that into a grammatically correct sentence. We're just looking at the syntax for it here. Hopefully you see that. Our comparison gets a lot easier because we go to the one that runs. We're now using the comparison that is more intuitive for most people than the dot equals method. So enums give us a way to buy back that equality because we don't have to take several milliseconds to figure out how much RAM we need, or if we already have that in RAM somewhere. It's a short list. We can check to see if that short list is already in RAM somewhere. And yeah, then Java allows us to add methods directly into our enum. Most of our other programming languages, we have to add methods into our class, and we just check the enum value. But it's nice to have that that in there. Anybody have any questions about the enums, the short list? You probably think of some things to do with them, right? Last week I asked to try to get a jump start on your homework if you weren't too busy. I know everybody's very, very busy. I know how school gets. But the first part of the homework assignment was kind of just data classes. Represent a real world object, a physical item or concept or something from the real world. Represent that as a data class. This one. I think that was just one part of the assignment we got module 3, which isn't due for a couple weeks still. Or is it next week? Yeah, it's almost October already. On that first one is create something. For those that I know some hobbies of and I've talked to before, I tried to think out something people would know, that you'll be familiar with and could describe a representation of. If it helps, like the fishing pole thing here, think about an online retail site. What details would your virtual representation of a fishing pole need for that online retail site? Or what details are involved in there? How many classes are involved in that, right? On a fishing pole, there should probably be 2 classes, the rod and the reel. They're separate things and we can mix and match them. There's standardization, so lots of rods will hold lots of reels. There's more than one size, but there's a couple different sizes that go on too, right? That'd be a good place for Enums. Different things. If you put in data about a guitar, there's some short lists that go in there. 6-string guitar, 7-string guitar, 12-string guitar. It's a short number of how many strings go on a guitar. There's usually a very short number of frets we can put on there. We can make any number of frets, but most guitars have either 22 or 24 frets. And those things with a short list. So if you started something, try to work an enum in that and come up with a short list for your data class objects. The other ones are straight out of the textbook. If you weren't here last Thursday, that first assignment is just pick something from the real world. I was trying to come up with a list, things that people would find interesting. If you have an idea, run it by me. Most of them are probably good. I did leave off video game character intentionally. So I'm pretty sure I mentioned that what really helped me learn object-oriented programming was programming video games, but I left that off here intentionally. I want a real world object or a concept. An advising appointment, registration is coming up for school soon, right? So what sort of, think about this scheduling an appointment with your advisor. What sort of data fields would be good to go in that? What's the information that's needed? What do you need to hold and things? What does the advisor need to know? What do you need to know? All of that information. And along that line, remember to register for classes sooner rather than later. They do get, if enrollment's too low, classes do get canceled. Otherwise, I think that was it for the example this evening. Does anybody have any questions? Okay, so real quick here, we changed the object 1 and object 2's stuff. So we need to put those back on GitHub. I close out of the repository. And then we were looking at we're gonna try to quickly look at the Git GUI. Those whole things are in here, so I'm just gonna copy those. So select both of those, copy that over to where that temporary file is, and Git stuff. There's already an object 1, object 2 folder, so if I just hit paste, it should overwrite both of them. 33 files were the same, so there should be some changes there. And this is in that particular folder. The main thing with the GUI though is when you go to clone your repository, remember you have to let the GUI create the folder. So you browse to the parent folder and then type in the name of the folder you want to create. We'll rescan this. So here's those 33 changes. Get a description on each one. Looks like they're mostly in the JavaDocs. Here's something. There's some actual code. And we get the green and red lines for what was taken out, what was put in. So a nice graphical representation of what's going on there. When all looks good, after hit stage changed. So I guess they use like the Broadway sort of referencing backstage. We're ready to change this. Our repositories up there on stage. Between scenes, we have to change out the stage, get ready for the next scene. I guess that's where the word stage came from, because it's not used anywhere else on repositories. What? I have no idea what that message was about. I'm going to ignore it. It told me to restart. Hopefully, it's not a big deal. Sign off on it is messages. So the short message goes on one line. Class example with Enum, JavaDocs, and Enum is what we did today. And then skip a line and then put the detailed description. A very long detailed description starts after skipping a line from the short description. Usually we don't ever look at those. I don't think we even talked about them before. Right? The short description is like if you're on the website, it's going to say a file upload. Or if you do it with the command prompt, you have, when you commit, you have the -n parameter. That's the single line up top. But we can put like a great big long detailed description as well. Most people don't do it, but if you want to do that in the GUI, just skip a line between them. If it needs signed, we're not going to sign it. Signing is optional, so I'm going to go ahead and hit commit. Notice that it pulled everything off the stage. And the last button, push it. And then options select what branch to push it to. The origin, same origin that it came from, or we could push it somewhere else. Force overrides, usually just right back to the main branch is good. And yeah, apparently whatever that warning message was didn't matter because got the green dot. We see how we get that color coding, like the green and red on the changes, and we can see everything happening along the way and all that in the nice little interface. And then one of the big, and we have all the information when it's down here, right? There's we can create new branches, navigate between our branches, merge our branches, do all the stuff we have for GitHub right here in the GUI. And in particular, the Get GUI, these two buttons right here, to visualize the history. I think this is the best visualization of the history on a GitHub repository we'll see anywhere. Everything, those are all item boxes, so everything there is clickable. Everything you see on that is clickable with links. So it's a really nice nice view of the entire history of your repository. Which also kind of helps to show the power of repositories over regular online cloud storage. As always, best way to learn is click around with it. If you don't have that, if you just use the regular GitHub, the original Git that Linus Torvalds created, that is Git SCM. So when you just say download Git, that what should be the top listing Git SCM that has all of the automatic high level credentialing, so you don't have to automatically enter you don't have to type in your passwords or tokens or anything. It's all handled as with OAuth objects in the background. The computers handle all the security, so we don't have to worry about it. Much more secure all around. And when you download that, you'll get the Git Bash, a bash shell, which will run your Windows system. So if you also just want to want to run your Windows machine with bash, because you're more familiar with that from Linux or Mac or something, that does work for that. Or the GUI or a command prompt. kind of goes the other way. If you want to run your Mac with the Windows command prompt, that'll work. You can configure it to do that way. But clicking around is a great way to learn things. It's an active subject. We learn by doing. And we have 45 minutes left to do stuff in our scheduled time. Does anybody have any questions before we wrap up here? Okay, I assume 5 seconds of silence means no questions, so that'll be about it for tonight, and we'll pick up with more object-oriented stuff on Thursday. If you have questions, let me know. I'm just gonna be sitting here till 8:50 and ready to answer questions, and unless everybody leaves, in which case I'll be the last person on campus, so I'll probably head back to Clarksville. But it doesn't take me long to get home, so within like 10 minutes, I'll be answering that question. Let me know if you have questions. I'll see y'all on Thursday.